Hey everyone, and welcome back to the Random Techno. Today, we will be learning about IP address structure. This is like learning the secret language of the internet, and trust me, it's way cooler than it sounds. By the end of this video, you'll be able to decode those seemingly random string of numbers like a pro. First, let's do a quick recap. So, what's an IP address again? Think of it as the unique postal address for your computer, smartphone, or any other device connected to the internet. Just like your home address helps the mailman deliver your letters, an IP address helps data packets find their way to the right device across the vast network we call the internet. And remember, we have two main versions, IPv4, which is like the old timer that's been around for a while, and the IPv6, the new kid on the block, designed to handle the ever-growing number of internet-connected gadgets. Alright, let's start with IPv4, the classic format. An IPv4 address like this one here is basically a 4-part code. Each part is called an octet, and they are separated by periods. Now, each octet is made up of 8 bits. A bit is the smallest unit of information a computer understands. This is either a 0 or a 1, like a light switch being off or on. Since we humans aren't robots, we represent each octet as a decimal number which can range from 0 to 255. Think of it like having 4 rooms in a house, and each room has 8 light switches that can be turned on or off. Now, these 4 octets aren't just random. They are divided into 2 important sections, the network ID and the host ID. The network ID is like the city and state part of a postal address. It identifies the specific network your device is connected to. The host ID, on the other hand, is like your house number and street name. It points out to your exact device within that network. But how do we know which part of the IP address is the network ID and which is the host ID? That's where the subnet mask comes in. It's like a secret decoder ring that works alongside the IP address. A subnet mask also looks like an IP address, but its job is to tell your computer which bit represents the network and which represents the host. Usually a 255 in the subnet mask means that the corresponding part of the IP address is part of the network ID, and a 0 means it's part of the host ID. For example here, the subnet mask 255.255.255.0 tells us that the first 3 octets of our IP address 192.168.1 make up the network ID, and the last octet 10 is the host ID. Let's visualize this with a fun analogy. Imagine a big office building. The building represents the network. Each floor in the building can be part of the network ID, and each office number on that floor is the host ID. So, if we use our previous example, the IP address 192.168.1.10 will be like office number 10 on the first floor of building 192.168. Now, in the early days of the internet, IPv4 addresses were categorized into different classes A, B, C, D, and E. It was like having different postal zones with slightly different address formats. Class A was for the huge networks, Class B for medium-sized ones, and Class C for smaller networks. Classes D and E were reserved for special purposes, but today we mostly use a more flexible system called CIDR, which stands for Classless Inter-Domain Routing. It allows for more efficient use of IP addresses, but the main idea of network and host IDs is still the same. Alright, let's move on to IPv6, the new generation of IP addresses. As you can see, IPv6 addresses look quite different. First, they use the hexadecimal numbers, which means they include not just 0 to 9, but also the letters A through F. Second, they are divided into 8 groups separated by colons, and each group has 4 hexadecimal digits. An IPv6 address is 128 bits long, which is 4 times longer than an IPv4 address. This allows for a mind-boggling large number of unique addresses. Just like IPv4, IPv6 addresses also have a network portion called the network preface and a host portion called the interface ID. So, why did we need this new IPv6 format? Well, remember that IPv4 can only provide around 4.3 billion unique addresses. That might have seemed like a lot back in the day, but with the explosion of internet-connected devices, from smartphones to laptops to smart fridges and even smart light bulbs, we are simply running out of IPv4 addresses. It's like trying to fit everyone in the world into a small apartment building. IPv6, on the other hand, can provide an almost unimaginable number of addresses, around 340 on decillion. That's 340 followed by 36 zeros. It's like having a gigantic mansion with enough rooms for every grain of sand on every beach on Earth. We need IPv6 to make sure every device can have its own unique address as the internet continues to grow. So let's wrap this up with some key takeaways. IP addresses are structured like postal addresses, with different parts that help route data to the right destination. IPv4 addresses are made up of 4 octets, and they are divided into a network ID and a host ID. The subnet mask is the key to figuring out which part is which. IPv6 is the future. It's longer, uses hexadecimal, and provides a practically unlimited number of addresses to support the ever-expanding internet. And that's it for today's lesson on IP address structure. I hope you found it informative and maybe even a bit fun. If you did, please give this video a thumbs up, subscribe to the channel for more tech explainers, and don't hesitate to ask any question in the comments below. I will do my best to answer them. Until next time, happy surfing.